Good morning and welcome to another Micrographics live webinar. Today's topic is Fusion 360 Generative Design and the extension. Unlimited Design Possibilities is the little subtitle here. I'm your presenter, Carlton Roy. I'm an application engineer with Micrographics, and my email address is carl@mjfx.co.za. So if you have any queries, you can send them on to that email address. This webinar is being recorded and will be posted up onto our YouTube channel. And if there are any questions during the course of the webinar, feel free to post them up in the chat and we'll answer them as we go through. On today's agenda, we are looking at an introduction to generative design, introduction to the webinar as a whole. Then we are going to look at what are the Fusion extensions. We'll have a quick one-slider on each extension. Then we'll have a deeper dive into what is generative design. After that, we'll look at the Fusion 360 Generative Design Extension. We'll close off with a summary and Q&A. And the value of generative design, you first need to understand some of the challenges you as an engineer may face today, or your employees as engineers or designers may face. Engineers are always trying to strike the right balance between the performance of their products and the cost to produce them. And time is never on their side. There's always project deadlines. They always have to get everything done. So they often just don't have enough time to explore all the ideas and options they would like to be able to innovate designs. And often the ideas the engineer will explore are limited by their expertise that they have. And it doesn't allow them to go outside of their comfort zone. So they're used to doing the same thing over and over again and get into kind of a groove or a rut and can't come up with new ideas, especially with time limits. And this is where Fusion 360 with generative design and the generative design extension comes in. And but before we look at this, let's have a look at what an extension is and what do the different extensions do for you as a Fusion 360 user or as a designer. So I pose the question, what is a Fusion 360 extension? Well, for Fusion 360, already comes with a very good base set of features. But for some users, however, this is not enough and they need more specialized features. Now, would these users now have to go and purchase other software packages? Maybe they need more specialized simulation. Maybe they need more specialized manufacturing capabilities and more specialized additive manufacturing or design options. Now, would they need to go and purchase other packages? Would they need to deal with more licenses and possibly even a new supplier to get this? And the short answer is no. They can expand the features available to them by subscribing to the relevant extension. In this way, they can continue to design and create in the same familiar package, Fusion 360. They don't have to leave Fusion 360 to access these advanced options. So let's now have a look at what extensions are available inside Fusion 360. So here we have a list of the extensions available. The slides following this will give us a quick, one-slide intro to each of these extensions. And at least this way, you'll be aware of what else is available before we go into our deep dive of generative design and the generative design extension. So as I mentioned, as a designer, you may want to specialize in a specific area, or you find yourself doing a lot of designs relating to something very specific. And so these extensions can quite possibly meet your requirements for more functionality in that area. And starting at the top of the list, we have the additive build for more advanced 3D printing, specifically for laser sintering. And we have additive simulation, which goes hand in hand with the additive build. So if you find you are needing to do a lot of additive manufacturing, 3D printing in metals, those two are a go-to. If you do a lot of machining, maybe you're a tool and die maker and you need to improve the performance, you need to get better surface finishes quicker, machining extension would be there. If you do a lot of flat components and you cut your own components in-house, laser cut or water jet cut components from sheet, then nesting and fabrication would be the one to look out for. If you're just a product designer and you want more options when designing products, and more specifically plastic products, the product design extension will be the one to look at. Simulation, if you find that you're doing a lot of simulation, you have the inbuilt simulation that's in Fusion 360. The simulation package would allow basically unlimited cloud solves. We have the managed package as well, which is extension to allow for lifecycle management of components, unique numbering, and that would tie in with the entire team to allow people to manage files better within a design team. And lastly, generative design, which we will be looking at in depth today. So for each of these, the slides we have, we're going to start off with the additive build. And the additive build extension lets you add metal powder bed fusion or SLM, sinter laser melting machines, or selective laser melting machines to your setups. So within Fusion, you would have those machines added in your setup options. And over and above this, you can adjust the machine settings as far as laser strength, coating layers. You'd be able to orient your parts and generate associative supports. Once this is done, you can then generate and visualize additive toolpaths and output a native build file, including laser parameters, or alternatively a 3MF file of your setup. Then the additive simulation extension allows you to create process simulation studies. This is a thermal mechanical analysis of part manufacturing using powder bed fusion technology of SLM, selective laser melting. Fusion 360 simulates a part's behavior during the additive manufacturing process and visualizes the result. The simulated result shows predicted displacements and projected print failures, like interference with the additive machine's recoater blade. So essentially, using a laser, you're going to add heat, the parts may warp. This will simulate that warpage and adjust. So the solve a process simulation study to confirm your designs, but it also allows you to find ways to optimize your process and also create compensated designs based on the predicted displacement. So it will actually warp the print to predict that displacement so that if it does warp during printing, you end with the correct shape. With the machining extension, this allows you to add extra features to the manufacture workspace to amplify the CAM capabilities of Fusion 360. This includes machining strategies to achieve a better surface finish quicker. It allows you to take advantage of modern machines with on-machine verification functionality, while also allowing you to trim and edit toolpaths without having to recalculate the entire toolpath. And lastly, it also gives you more control over 5-axis machining. So machining extension, as I mentioned, for those who are in tool and die making, this helps out a lot, especially if you have a newer machine where you can probe the component on the machine for quality checks or even to help with the setup. There are even functions in here to probe and realign your G code to the actual component, the way the component is clamped in the machine. Then move on to nesting and fabrication. The nesting and fabrication extension allows you to arrange flat parts, or otherwise known as nesting, within a specified area to optimize material usage. This also has controls over the part orientation, and more recently in updates also allows you to set up grain orientation. So if you are working with wood components, you can also specify the grain direction per component to allow for your nesting to align the grain to the board. Over and above this, you can set up your stock materials that are available to use for nesting. So you would set up your various materials: steel, aluminium, wood, melamine, chipboard, various materials you use and you want to nest with. And when you generate your nest study, those materials are pulled from your stock to use, or should I say from your library to use, and a report will also be generated to show you the part layout, the material usage, and more information with regards to wastage and the actual nesting itself. Then we come to the product design extension. The product design extension gives you advanced tools to automate the design of complex plastic features. You can apply intelligent patterns and add shape-altering properties to your design. You can also receive manufacturing-aware advice to improve your product performance and prepare your designs for manufacturing. This empowers your designs process and turns your ideas into a finished product faster. Just to highlight some of the nice tools here, we have plastic rules, which allows you to assign plastic rules to components to automatically control the properties of plastic features. We also have plastic design tool options where we can use things like Boss and Snap Fit tools to create plastic features. And we can actually see those two images on the top. We have the Boss on the right and the Snap feature on the left. We can also create geometric patterns so that we can create complex patterns with adjustable size and distribution gradients across a selected face. So we think of something like a speaker grill. We can see on the left-hand side there, or the bottom of those two images, the left-hand side, the start product, the right-hand side, the end. We've got that pattern that starts with a bunch of circles in the middle, and it slowly reduces in size of gradient as that pattern works its way out on the face. We can also convert organic meshes into solid surfaces or T-splines. And then with volumetric lattice, this allows you to modify existing solids or closed mesh to create a complex volumetric lattice that alters the shape and appearance of the design. So if any of you have 3D printed before, your infill in a 3D print is basically a volumetric lattice. So yeah, this allows you to design a component using volumetric lattice and generating a lattice structure inside of your component. And also there is design advice, which allows you to identify manufacturability concerns based on industry best practice and company standards, and receive recommendations to improve the manufacturability and performance of your design. We then have the simulation extension. Essentially, the Fusion 360 simulation extension is a set of study types to help you investigate if your 3D design can be manufactured or how it may perform under real-life conditions before manufacturing anything. So you can analyze performance and manufacturability of your 3D designs to ensure they will meet the demands of real-world conditions, the structural, thermal, and explicit simulation tools. So the simulation extension also includes injection molding simulation studies to help you in gaining plastic injection molding manufacturing insights for your 3D design. Now, you may wonder, well, we get that in Fusion already. However, those cloud solves do require credits to solve. So when you unlock the simulation, that simulation basically gives you unlimited cloud solves. So you're no longer using credits to run those simulations. So essentially, the standard simulations in Fusion, you're just unlocking those cloud solves. Then we get to the Fusion 360 Manage extension. Now, the Manage extension builds into Fusion 360 item numbering, so you can create unique item numbers for components. Then it allows you to link life cycles to those items, so your components can go through life cycles and revisions, and all this is controlled by change orders. And as your components go through change orders to manage revisions on components, as well as managing release information. So when do you release it to manufacturing? The Manage extension will allow you to have all that extra control, and it also gives you expanded user management. You can create user groups and roles, and you can manage that a lot tighter than you could in the standard Fusion. And then lastly, we get to the Fusion 360 Generative Design Extension. And if you're a designer and use generative design on a continuous basis, then you'll most likely want the Generative Design Extension. The reason for this is that it gives you unlimited access to all generative design functions for 1 year, meaning that you do not need to spend the 33 credits per study to generate your outcomes. So this unlocks those outcomes, so those generations of the outcomes, no need to pay the credits per generation of outcome. So let's have a deep dive into what is generative design. So, as I just said, what is generative design and why is it a paradigm shift in the industry? Well, generative design is an artificial intelligence-based design exploration technology available in Fusion 360. The benefit of design exploration is the ability to simultaneously generate multiple CAD-ready designs based on real-world manufacturing constraints that meet product performance and cost requirements. This allows engineers to focus their minds on innovation and solution selection instead of low-value add tasks. So in a nutshell, your designer would input the fixing constraints, the force requirements on the component, the manufacturing requirements on the component, the material requirements, and the AI on the cloud will calculate various design outcomes. This includes manufacturability or the manufacturing process as well. On screen, we have images of what would be created through additive manufacture. Yeah, maybe possibly sand mold or die cast using sand molds, but typically that would look like a 3D printed part. But you can also specify other manufacturing processes and get various outcomes of the design. So let's have a look at the generative design process if we're looking at design exploration. One of the benefits that generative design provides is very early in the design process with extensive design exploration. You can see here in the timeline, the iteration phase is very short with a lot of outcomes generated right at the beginning. And so this allows engineers to explore multiple design options consisting of different materials, manufacturing methods, and manufacturing costs very early on. Some of these shapes go beyond human imagination would come up with. That's a schema, and that was generatively designed. And so this empowers the engineer to select the best design option, and it's already validated and ready for production. What I mean by already validated is that to create the design, as I mentioned earlier, the fixing of the fixing points, the force points, the forces required, the material, all of that information is put in right up at the front to calculate out the design. So we find that the iteration phase is a lot shorter. And after that, your design to production phase is reduced because you are producing less prototypes. That back and forth to produce, test, redesign, produce, test, redesign is shortened drastically and your productivity increases. We can see there on the right-hand side, we have that productivity increase at the end of the day. And so looking at the process, what is the design value? What is the generative design value here? So starting at the top with improving product performance, lightweighting is becoming a big thing in the industry, especially if we look at, let's say, electric vehicles. We're wanting to reduce, or manufacturers are wanting to reduce the weight of components so that batteries can last longer and get more range. Machines with moving components, if you reduce the weight of those components, that machine can cycle faster. It can use smaller motors to cycle at the same speed even. And so you can reduce costs there. You can also increase structural integrity. As I said, you've put in all that design information up front with regards to forces required. And this also leads to extended durability. Going down to the second point with increased productivity, you're able to explore more design alternatives. We saw that in the previous slide with all the different design alternatives spat out to give the designer options to choose from. And they expand beyond the human imagination, things that you would never have thought of. And this saves the engineer time during the iteration and design phase. And at the end of the day, this reduces your product cost. You can consolidate assemblies into a single part. You're able to reduce the amount of raw materials, and we have some success stories. And you can explore different manufacturing methods for the same components. And at the end of the day, what this does is it helps you win more business. It improves your time to market, and it can improve your profit margin. So if we move on to the manufacturing methods, one of the key requirements for generative design is the exploration of various manufacturing methods. Autodesk is unique in the industry by supporting the generation of shapes that adhere to several common manufacturing methods. The Fusion 360 Generative Design Extension supports additive manufacturing as well as die-cast, 3 and 5 axis milling, 2.5 axis milling, and 2-axis cutting, essentially laser or water jet cutting, even plasma. This allows you to use generative design in almost any manufacturing workflow, not just additive manufacturing. So how does this affect your insight into manufacturing costs? So once you can generate those outcomes that support multiple manufacturing methods, you then need to select the best one for your product. So another key element in the selection process is determining how much it will cost to produce the required components. Autodesk's partnership with a priori enables them to calculate manufacturing cost insights for each generative design outcome. This is the first of its kind in the industry, and Autodesk are the only ones introducing this variable into generative design, coupled with supporting multiple manufacturing methods and multiple manufacturing methods and materials. Generative design can empower the engineer to make the best design decisions possible. Let me demonstrate with this graph. The light green line that runs almost horizontally is the price to make components using additive manufacturing. As you can see, there's not much discount for production volume. So we see at the bottom, production volume is our scale at the bottom, cost per part is our scale at the left. And it's not super high, super expensive for the first few units, but you don't get much discount as far as creating or printing more units, mass producing. Now, on the other hand, die casting, the die casting option with the blue line provides high scaling benefits, but the initial cost is high due to the tooling requirements of the actual die cast mold. And finally, you can see with the dark green line for CNC subtractive milling, there's some benefit to scaling with fixturing and automation, and this provides a good all-round price point. Now, if we look at the junction points, this allows the engineer to pick the best design for their production requirements. So we can look at cost and production volume And if we are running low volumes to the left-hand side, additive machining or additive manufacturing may be the way to go. We can see there that it's sitting below the cost of die cast and CNC. But if we're running in the mid-range, we have the CNC milling intersecting with die cast and additive, and that becomes effective. And then when we start looking at larger volumes, mass production, we then look at die cast as a feasible option as it drops below the cost of CNC milling. So these insights will be built into the software to be able to compare your production volume with the manufacturing process. Now, here's an example of MJK Performance. They developed 3 new design options to compare against the original design created by a human. As you can see, the additive outcome is very expensive for their production volume. So that would be on the far right-hand side. Additive generative weight, 2.2 pounds, kilograms. And we can see the 2.5 axis outcome meets their price requirements and offers a 23% weight saving for their performance motorcycles. So we looked at the additive design on the far right-hand side. That weighs 2.2 kilograms, saves 26%, but it's very expensive to produce in low quantities. However, the 2.5 axis, the one highlighted in blue, is only 100 grams heavier, but it is a lot cheaper to produce using 2.5 axis machining. So to conclude this segment, let's walk through the generative design process inside of Fusion 360 using this MJK example. So here we have the motorbike. We're isolating the component and we are preserving regions. These are the regions that are important. They interface with the rest of the motorbike. So that geometry will be preserved. Part of the generative design process is to specify what geometry to keep. We're adding structural constraints. We're fixing the outer 2 collars. And we are then going to add a structural load to the central collar. Now add the design criteria where we are going to set the safety factor. We're going to look at modal frequencies. And then we're going to look at production, manufacturing, 10,000 parts. We're going to try additive, unrestricted milling. Under milling, we'll add 2.5, 3 axis, and 5 axis. And we'll also look at 2 axis cutting. Generating this is going to create multiple outcomes. Here we can view the outcomes and we can group them by visual similarity. And all these outcomes can also be viewed either as graphic or as a graph where we can adjust the axes of the graph. Here we've got estimated manufacturing costs versus the mass in kilograms, and you could change vertical axis as well. So we're looking at what is going to work the best and what's going to have the best cost. And that geometry is output and is also then editable. So here we can see that they are tweaking the geometry to get the final product. Once they have the final product, it can move on to the manufacturing workspace where the machining can be applied, the machine programming can be done on the component. Here we see it being machined using 2.5 axis process. So, as we saw in that example, MJK, they are performance manufacturers of motorcycles, and they were able to design a new triple clamp component in hours that resulted in a lighter design that improves the performance of their motorcycle. The final design they brought into production used the very common and traditional 2.5 axis milling, machining or manufacturing method. As you can see on the top design, just related in the video, and this allowed them to offer great performance to their customers at a good market price. And as you can see from this customer success example, generative design is not just for large customers using additive manufacturing, but for everyone. This is an interesting example. The bottom design there was also a design that came out, and that was using It was 3-axis milling, where they were able to mill and use the surface finishing, possibly even up to 5-axis on that. Or it could be additive manufacturing. So just comparing, simple manufacturing methods with more advanced manufacturing methods on those components. Now, Claudius Peters, another success story, is a manufacturer of cement and gypsum plant equipment. And they used Autodesk Inventor as their primary design tool. They were able to reduce a casting to use a weld manufacturing method. They were able to redesign a casting to use a weldment manufacturing method that reduced the weight by 60%. That also saved them $7,000 per cooler that they produced. So they leveraged the Fusion 360 generative design technology, and they were able to take their Autodesk Inventor designs to a new level that resulted in real business impact by reducing. So we spoke earlier about material savings. Essentially what this company did was they used generative design to suggest a new shape for their design. They took that design, that shape, and they broke it down and looked at, okay, can we weld this up in-house out of plates using the generative design shape as a starting point for the design? So there they used the generative design as an exploration tool to then in-house a process. So no longer were they casting, they're getting castings from a supplier, but they brought it in-house and they weld those components, saving a lot of material in the process. Then there are a couple more examples here. The GM example on the top right-hand side, that is looking at where we're talking about, reducing assembly complexity down. So that one there consolidated 8 components that were stamped and welded together into one single part. And this reduced a lot of labor cost as well as supply line simplification through that process. Another one worth looking at is Goodyear, bottom left. This is quite an eye-opener. They have a internal production hand tool, so a tool that is used when laying rubber down on the tires. And they replaced aluminium with nylon and 3-axis machining with additive. And so they took a $1,000 piece of aluminium that took 4 to 6 weeks lead time to machine and create. And they reduced it down to a $65 nylon part, which printed in 8 hours to get it ready for production. So huge reduction in cost and lead time in that example. So now let's look at the Fusion 360 extension offerings. We've looked at essentially the generative design extension offerings. We've looked at what generative design is. So let's look at what the extension offers. So Fusion 360 extensions, we had 8 extensions now. And, as discussed, Fusion 360 offers several extensions to extend the base Fusion 360 capabilities with additional functionality. The generative design technology is packaged into the generative design extension. It allows engineers to design without limits. So the idea here is that there are 2 different business models. So Fusion 360 extensions are available in those 2 different models. There's the Flex Access model that is a pay-per-generate using Autodesk Cloud credits or tokens. So if you're looking at just generative design on its own, you're basically using that Flex Access. You are paying per model that you generate. Then there's the subscription offering that provides unlimited access for a year to the generative design extension. So there we have the subscription, generative design extension, unlimited access to many design generations as you want, or outcomes as you want for a year. So that provides the choice of access, providing flexibility to remove barriers for adoption. And also the Flex Access allows someone to pay as you go. It allows you to pay as you need it, or you could even purchase large cloud credit packs and use them as needed rather than paying for a full year subscription if you're not sure if you're going to use it. Then your subscription offering for generative design is great for when you have users that are using generative design on a regular basis and would like a fixed price. So if you're using it almost every week, it's worth going to that design extension so that you have that unlimited generation capacity. And lastly, we'll have a look at, we'll look at it slightly differently here. You start with your base Fusion 360 subscription, which could be a subscription on its own or included with other products like the product design and manufacturing collection. So you have your base subscription. With that base subscription, then you can choose them between purchasing cloud credit packs, for example, a 5,000 or 10,000 credit pack, and to give you that flex access, or you can purchase an annual per user subscription of the Generative Design Extension, which, as I said, gives you the unlimited capacity in that generative design environment. No need to pay per study. And so, in summary, I would just like to say that the extensions equals more functionality and possibilities. Today's webinar was specifically looking at the Generative Design Extension. That extension, like I said, unlocking the unlimited solve, so there's no credit cost, and this allows you to create design iterations quickly without worrying about cost. It allows you to maximize your performance, creating those studies, getting the different designs back, and allows you to balance complexity with manufacturability, all while not worrying about the extra cost of every solve that you create, every generative study that you do. And so you're able to give the designer more freedom to explore, more freedom to innovate within the design environment. And that would bring us to a close. I'll open up for any questions before we close off the webinar. Okay, there are no questions. Thank you for your time, for watching this webinar. As mentioned, it will be posted up on YouTube as well, on the Micrographics YouTube channel. Once again, my name is Carl van Rooyen, Fabrication Engineer. Thank you so much for your attendance.